Hello everyone, and in this particular video we shall discuss the addition of hydrogen halides to unsymmetrical alkenes. Okay, so let us first try to understand the unsymmetrical alkene addition, and for that I would like to take into consideration of this particular example, and that is CH3 CH double bond CH2, and that is the propene. Okay, so let's take propene into consideration. Now, when propene acts with hydrogen halides, now it gives rise to two types of products. But the nature of major product depends upon the reaction condition. Try to understand this. So, what is going to happen over here? When we are going to have this particular reaction, it all depends upon the reaction conditions. Okay, so depending upon the reaction conditions, I am going to get two products, of course, and in these two products, one product is going to be at the maximum amount. The particular product which we get it at a maximum amount, we call it as a major product. And the particular product which we get after the reaction in a minimum amount, it's a minor product. Okay. So therefore, we are going to get over here two products. Doesn't matter what is the reaction condition, but the nature of major product. Okay, the nature of the major product depends upon the reaction conditions. Okay, let us take this example, let's solve it and let's try to understand this. So if I have this CH3, CH double bond CH2, adding this one with hydrogen bromide. Okay, so what we are taking here? Hydrogen bromide into consideration. So if this particular reaction occurs, this reaction, as what we have, it follows Markovnikov's rule. Okay, so what it is going to follow? It is going to follow Markovnikov's rule. Okay, so it follows the Markovnikov's rule. In the Markovnikov rule, it says that the negative part of addendum. So this is a thing which is going to add. Okay, so negative part of this particular thing, that is the negative part of HBr. If I am going to take over here HBr into consideration, okay, what I know, this particular Br is more electronegative, correct? Due to the electronegativity, this is going to be the negative part, this is going to be the, of course, the positive part. So according to the Markovnikov's rule, the negative part of addendum attaches to that particular carbon which has lesser number of hydrogens. Okay, so according to this, the negative part of addendum attaches to that particular carbon atom of a carbon-carbon double bond which has the lesser number of hydrogen. That means this particular bromine will attach to the central carbon here. So when it attaches to the central carbon over here, then we are going to have it as CH3, CHBr, right? Now what remains is hydrogen. This hydrogen attaches to the CH2. So therefore, we are going to end up writing here over here as CH2 becomes as CH3. So I'm going to get here the product that is 2-bromopropane. Okay. So 2-bromopropane is going to be the major product. Okay. So the reaction is occurring with respect to Markovnikov's rule. This is how we can call it. So plus, what we have? The next one. In the next one, you can attach the bromine over here. Okay. So when it attaches the bromine over here and the hydrogen to the central carbon, we are going to end up getting over here CH3, CH2, CH2Br, and that is the 1-bromo. Okay, 1-bromopropane, right? So 1-bromopropane is going to be the minor product over here, right? So minor product is 1-bromopropane. Now, we have gone through the Markovnikov's rule. Okay, so now let's try and understand why did we get these two type of product, and why especially the 2-bromopropane became the major product, and why did 1-bromopropane became the minor one. So we need to understand this by the help of a mechanism is concerned. Okay, so let's wait for the mechanism. When we take a look into the mechanism of the addition of the alkyl halides to an unsymmetrical alkene. Okay, so according to this particular equation, as what we have already discussed, we are going to have it as CH3 CHBr major product over here plus CH3 CH2 CH2Br as a minor product. Correct? These two products we have already obtained. Now we need to understand why was this particular thing as a major and why the next thing was as a minor. Okay, so when we take a look into the mechanism, so the mechanism contains 3 important steps. In the first step, it is going to be the generation of electrophile. Okay, so electrophile, the generation of an electrophile. Electrophiles are those particular species which contain positive charges. Correct. So therefore, our first reactant is this particular hydrogen halide. Okay. So from the hydrogen halide, specifically over here, hydrogen bromide. This hydrogen bromide splits in a heterolytic cleavage. That means the bond breaks. When the bond breaks in a heterolytic cleavage, what is going to happen is that bromine, being more electronegative, takes the electron with it. Okay, so as it takes the electron with it, it becomes as Br minus. Hydrogen loses its own electron, so therefore it becomes as H plus. Hydrogen ion, you can call it as a proton, you can call it as an over here as hydron also, no issues. Okay, so therefore I would like to call it as hydrogen ion. So hydrogen ion is produced, and this hydrogen ion is nothing more than our electrophile. So in the first step, what we have generated is the electrophile. In the step 2, this electrophile plays an important role. That is, it attacks the carbon-carbon double bond. Okay, so therefore, in the step number 2, what is going to happen is the attack of electrophile. Okay, now where is this particular electrophile is going to attack? It is going to attack to the alkene. Okay, on the double bond of alkenes. Alright, so quite simple. So when the hydrogen is going to attack, so if you observe, what we have here is CH3 CH double bond CH2. Okay, so now there are 2 possibilities. Try to understand it. So here H plus. So if this hydrogen ion attacks to, let's say, let us mark this one. This is carbon number 1 and this is carbon number 2. Okay, let's have it like this. So when the hydrogen ion is going to attach to carbon number 1. Okay, it has no electrons with it. So therefore, it will try to take the electrons which are between carbon 1 and carbon 2, that is from the pi electrons. Pi electrons are delocalized electrons. So these delocalized electrons will move to carbon number 1. That means carbon number 2 has lost electrons, because those electrons have come to carbon number 1, and carbon number 1 will pass it over to the hydrogen ion. So therefore a bond is formed between carbon 1 and hydrogen ion. Alright, so therefore we are going to get our first intermediate stage, and that is CH3CH. This fellow has lost the electrons to carbon 1. So therefore what we are going to get? a positive charge over here. Okay, now this hydrogen is attached to this. So CH2 becomes as a CH3, right? So this is our CH3 here. Now, let us consider the second point. Try to understand. Here, the carbon had attacked carbon number 1. Sorry, here the hydrogen had attacked carbon number 1. Right? Now, let's reverse the process. So now, hydrogen ion will attack the carbon number 2. So if it does the same way, CH3, CH2, CH CH2 with a positive charge. Okay, so we have two conditions here, 1 and 2. Okay, now this condition over here that is going to represent to us a secondary carbocation. Now remember, secondary carbocations are more stable, right? So as they are more stable, they will react more. The reactivity is more with, where it is, yes, with Br minus. Okay. Now on the other hand, what we have is this particular condition, where you can see that the carbon over here is the primary carbocation. Okay, so primary carbocations are going to be less stable. Remember the point. Okay, so therefore, what is going to happen is, because of the more stability of the secondary carbocations, they are going to react more effectively with the Br minus ion. Okay, so as they are going to react, so what we are going to have is the step number 3. The attack of Br minus on carbocation, right? So when this particular reaction occurs, what we already have there, CH3, CH with a positive charge, CH3. Okay, so now when this Br minus attacks to the secondary carbocation, you are going to get your product in the measured quantity, and that is CH3, CH, Br, CH3. Correct. Now, here, this is more stable. Correct. So, therefore, its rate of reaction is more. So, it is going to give us a major product. It does not mean that this one is not going to react with Br minus. Even this one will react with Br minus. But here, the primary carbocation has less rate of reactivity. Okay, so due to this lesser rate of reactivity, its reactiveness towards Br minus is going to be less. As it is going to be less reactive with Br minus, it is going to form as the minor product here. Okay, so this is how it all goes. So this was all about the Markovnikov rule. Okay, so I hope you people have understood about the Markovnikov rule. Do take care. We'll see you in the next video.